Or I think you will be very fine at your home. My dear, I welcome you all in the grade 10's math online classes. My dear student, today the topic polynomial, which is a chapter of your book. You know about polynomial, about the degree of polynomial. Degree of polynomial always will be non-negative whole number, neither negative or in the fractional form. Understood? Before knowing about polynomial, we have to give a glance on an algebraic expression. An algebraic expression in which variable or constant are joined together, combined together with the mathematical symbol. Okay, suppose I am taking an example of algebraic expression like 2x plus 5. Here is a variable. This is a variable and two and five. The 2 and 5 are constant. This is a variable and constant. You know about variable which value varies, not fixed value, and constant having fixed value. So this is the combination of variable and constant. And very clearly, an algebraic expression is a combination of variable and constant, which is separated by mathematical symbol like plus, minus, divide, etc. Okay, you know about polynomial. I said you degree of polynomial must be non-negative whole number. Poly means many and nomials means terms. In the polynomial, many terms on the basis of terms. There are several types of polynomial. Suppose I am taking example. This is a 2x single term, one term. It is a monomial. Two term binomial. Suppose there is a three term. There are three terms. It is a trinomial. On the basis of term, later quadrinomial, so on. And on the basis of degree, this is one. On the basis of degree, first one is a linear polynomial, linear, linear polynomial. Standard form of linear polynomial, ax plus b. This is a standard form of linear polynomial where a and b are any real number and a is not equal to 0. If a is 0, then it will not be a linear polynomial. It it will be constant because this is constant. Okay, and what you are looking here, having the degree of variable, having degree equal 1. If degree 1, certainly there will be one value. What? Zeros is equal 1 also. This is the identification of the linear polynomial. Suppose I am taking 3x plus 5. This is linear polynomial. Why? It is a polynomial in x having variable. This is a linear polynomial in x having degree 1 and certainly it has 0. You can guess. Suppose here is a px is equal 3x plus 5. Which value will satisfy? P's value minus 5 by 3. 3 into minus 5 by 3 plus 5. This will cancel. 0. Certainly minus 5 by 3 is a value of this polynomial. And what you are looking? On the basis of this, we can write here px is equal ax plus b. Therefore, p minus b by a. P minus b by a is equal 0. It means this is constant term, this is coefficient of x. Coefficient of x. Okay, I am going to erase the blackboard. Yes, later. Hello. Now we will discuss about the graph of the polynomial. Graph of linear poly. Which type of graph will be the linear polynomial? Certainly, it has a straight line graph. Suppose let fx is equal 2x plus 5. Therefore, let y equal 2x plus 5. Okay. To find the graph, at first we have to take the value. Here is y equal to x plus 5. Here is x. Take 0. Here will be 5. 1. What will be? If we will take 1. Suppose here is minus 1. 3 minus 2 plus 1. Okay. Now I am taking the graph, showing you which type of graph will be of the linear polynomial. Okay. This is a vertical line, you know. Vertical line is known as y-axis, and this is a horizontal x dash. Sleeping line is a horizontal x-axis. We will take 1, 2, 3, 4, 5. Should be on the graph paper. You will try your best. This is the y-axis, okay, and 5. We will write here also on the y-axis minus 1, minus 2, minus 3, minus 4, minus 5. Oh, here also minus 3, minus 4 and minus 5. Okay, now I have to show it. On x-axis, what is 0? Here and at the y-axis plus 5. Here will be, yes, on the x-axis here is a minus 1 and y 3. At the x-axis minus 2, y-axis 1. Suppose, join this. First 0 and 5. Where is 0? Here. Okay. 0, 5. Right? Second is minus 1, 3. This is minus 1 and here is 3. Here is a 3. Minus 1, 3. Okay. Now you have to make a line. You have to draw a line. Look from where it is going. It cuts x-axis, y-axis here. Which type of line is this? Straight line. This line is a y equal to x plus 5. Clear? You will draw it on the graph paper and you will understand it very clearly. Now the turn of quadratic polynomial. What? Quadratic polynomial. General form quadratic polynomial. This is quadratic polynomial. Standard form of quadratic polynomial is ax square bx plus c, where a, b and c are any real numbers or a is not equal to 0, having degree equal to zeros equal to at most 2 0. This is the standard form of quadratic polynomial ax square bx plus c. Understood? Now you have to show that which type of graph of linear quadratic polynomial will be. My dear, you know two types of graph. Suppose the such type and this type will be on the x-axis. This is called parabola. Graph of quadratic polynomial. In the such way, just like linear polynomial, you have to show the graph of quadratic polynomial. Graph of quadratic polynomial comes in the form of parabolas, just like u-way. Suppose this is axis y-o, y dash, and this is x dash o, x-axis. You can say just such type of graph comes by the quadratic polynomial. Here is a two distinct cut it cuts at x-axis at a 2 point. You can say this is, you can say 2 zeros here. I am giving you a question. Suppose that, my dear friends, one question is like 2x square minus 4x plus 8. 2x square minus 4x plus 8. It is a form of quadratic equation. Polynomial. You can show graph of quadratic polynomial on the graph paper. You have to do and show me. Later, I want to go ahead. My dear, now it's turn of cubic polynomial. Cubic polynomial. Standard form ax cube bx square cx plus d. But the same way, here a, b, c and d are real number and a is not equal to 0, degree 3, and it has one or at most 3 zeros. Okay, this is the cubic polynomial. Later, biquadratic polynomial having degree 4. I will not go there, but I want to show you a relation between the quotient and its 0. Suppose linear equation in a linear polynomial, in linear polynomial, you know ax plus b, this is the linear polynomial, and here x is equal minus b by a. This is the zeros of this polynomial. What is b here? B is a constant. B is a constant. And what is a? A is a coefficient of x. This is the relation of the zeros in quadratic polynomial. Quadratic polynomial. You know the general form ax square plus bx plus c is a quadratic polynomial. It has two factors. If suppose fx factor x is equal ax square bx plus c, it has two factors like x minus alpha or x minus beta. Here x in 1 0 is known as alpha, second beta, third gamma, like this. Okay? Quadratic polynomial, here it has two factor like x minus alpha or x minus beta. Okay, I am going to erase the blackboard. Yeah. Hello. Fx is equal ax square bx plus c. You know, I said you by the factor theorem it has two factors. What's it? X minus alpha or x minus beta. Here alpha and beta are the zeros of quadratic polynomial. I said you earlier. It has two zeros, alpha and beta are zeros, and factors x minus alpha or x minus beta. Okay. Suppose fx is equal, if these two factors x minus alpha into x minus beta. Take a constant x, do multiplication, fx is equal x into x minus beta, here minus alpha into x minus beta. Yes, I am taking k here. K is a constant. What is this? X square minus x beta, here x alpha plus alpha into beta. I have taken k as a constant. Okay, x square, here is a minus x beta minus x alpha plus alpha beta. By the separation, okay, here x square, take common x, alpha plus beta will be by taking common. What you are looking? This is also okay. Suppose kx square minus kx into x plus, alpha plus beta. What alpha beta? Here zeros of the polynomial, quadratic polynomial, and this is the alpha into beta. Here also k alpha beta. You are looking here. This comes after the multiplication of the factors of the quadratic polynomial. Now here this is ax square. Suppose here ax square bx plus c. Now I am going to establish relation between the coefficient and zeros. So what you are looking, x square. Here k is the coefficient of here a. This is the coefficient of b. Coefficient of x is b. Here coefficient of x is alpha plus beta, and this is by the comparison between these two form of quadratic polynomial, we know that alpha plus beta is equal. Alpha plus beta is equal, here is minus b by a, coefficient of x square. This is constant term here. We will take k is equal 0. It will be same. Minus b by a, this is constant, and here a coefficient of x square. Clear? Now this is the sum of zeros. Sum of zeros. And here is the product of zero, alpha into beta. this C by A. C by A. Same constant term by coefficient of x square. In this way, you can establish the relation between the coefficient and zeros of the polynomial. On the basis of the topic, I will give you some question in my next video in the written script. Okay, but before going to off, I want to say you, please prepare, write all the tau term on your notebook. Best of luck. Thank you.